Types of faults by Alex Moore. So a fault is not those first two definitions, but that last one. It is an extended break in a body of rock marked by the relative displacement and discontinuity of strata on either side of a particular surface. Wow. In layman's terms, because not all of us are crazy super awesome geologists, it means that there is a split between two sides of rock, and that fault is defined or determined by how those two sides of rock move in relation to one another. So the key thing there is movement. With faults, there's two main types. There's lateral movement and there's vertical movement. Within lateral movement, there is more of a side-to-side type of movement, and vertical, as the name would suggest, means that the two sides are moving up and down in relation to one another. With lateral movement, you have the strike-slip fault, also known as the transform fault. This happens when two tectonic plates are rubbing or shearing against one another, and the pressure builds up. Eventually, that pressure is released, and the two sides slip past each other. This creates a lot of geologic features like rifts and valleys and displaced rivers, a lot of flat things. On the vertical side, however, things get more interesting. These are called dip-slip faults. And these come in two different varieties, the normal and reverse types. On the normal side, you have tension forces pulling away two tectonic plates, and then the underlying plate and the overlying plate. The underlying plate is exposed as the overlaying plate is moved down. This creates a geologic feature called a block mountain, which essentially looks like someone went below and pushed up a square peg of earth. It looks pretty cool, actually. On the reverse side, it's essentially the exact opposite of the normal side. You have compression forces pushing together two tectonic plates, and the overlaying side is going on top of the underlaying side, kind of creating a sort of shelf. This makes a much more dramatic type of mountain, and it's typically how we normally think mountains are made. Some famous examples of both of these, you have on the lateral side the San Andreas Fault and the North Anatolian Fault, which both created some really cool deep rifts. On the vertical side, we have the Himalayas and the Rocky Mountains, which were created by reverse faulting. But what happens when you have both a lateral and vertical movement within a fault? Well, these are called oblique faults, and they occur when you have a combination of the shearing force found in transform or strike-slip faults, and also you have the compression or tension found in the dip-slip fault. These create some really cool-looking mountains. Some examples are the Kawecas, and the Ruahines Mountains in New Zealand. And that's pretty much it, actually. There's not too much more to explain past that, because there's only 4 different types of faults: lateral, normal, reverse, and oblique faults.